Again, your paper will look a little different than mine, but don't be confused. When I make the videos, sometimes I realize things that are missing or things I wish I had. So we're going to start with this one. Again, in your brain, I hope you are asking yourself, can I make it simpler? Is there a greatest common factor? Oh, absolutely there is. I can take out a 2. That would leave me with x to the 4th minus 81. Great job. We did make it simpler. We did factor it some, but we did not factor it completely. So I notice I have a subtraction sign with a binomial. So I'm curious, is that a perfect square minus another perfect square? Well, what do you think? Is x to the 4th a perfect square? Is 4 a perfect square? It is. It's 2 times 2. That means this is a perfect square minus a perfect square. So that I don't lose my 2, I'm going to drop it down. I'll take the square root of the a term to get x squared. I'll take the square root of the c term to get 9. So we will have x squared plus 9 times x squared minus 9. Phenomenal. Okay, we did some more simplifying. Are we done? I'm going to check. Can't do anything with the 2. Oh. What do you think about x squared plus 9? Can I factor that? Can I break it apart? Notice there is not a b term, so I wonder if I can. I do not know. We'll have to come back to that. But immediately, my eye catches this one, perfect square minus perfect square. So I'm going to just ignore that one for a second and take the square root of the a term, square root of the c term, and then I would have plus or minus. Okay, I'm going to erase that. Yours will be printed in the right location, and I will add it in just a second. But I want to talk about this term. I'm going to not put it in green. Green and blue look a lot alike. Could I factor, because it's a plus, would that be x plus 3 squared or x plus 3? Would that work? Because then I would get x squared as my a plus 9. But if I FOIL this out, oh, I now have created a b term that doesn't exist. Okay. What if I say x minus 3 times x minus 3? Because again, that would get me my x squareds in the beginning for my a term. And it would get me my plus 9 for my c term. Oh, but look, I have created a b term of -6. When you see this, you may not factor any further. This portion of it, I hate the word prime, but you can kind of think of it as a prime situation. So my final solution for this math problem would be this right here. And when it comes to graphing, I'm going to save that for Algebra 2 because there's a lot of things going on. Okay, I'm going to draw a squiggly line. I will rewrite the problem I had a minute ago written down. I realize I did not provide myself much room, but we're going to kind of follow the same steps as we did right here. Question 1, can we make it simpler? We sure can. We can take out a 3. That would leave me x to the 4th, and I forgot what that is, so hold on. I'm sorry. I need to do 3888 divided by 3 minus 1296. I forgot to write that step down. Okay, I'm excited I was able to factor some. Because I factored a little, I cannot use the word prime. Now, before I get too excited, I noticed a subtraction sign with a binomial. Is that a perfect square times or minus a perfect square? So that is what I'm curious about. And I know after playing on a calculator, that is the square of 36. So I would have 3 times the square root of the first term times the square or plus the square root and then minus the square root of the third term c. Again, we keep making it simpler. Did we make it the simplest it can go? No, but we did a great job. We took out the greatest common factor here. We noticed we had the difference of perfect squares, so I did the square root of the a term, square root of the c term. Now, before I can say I'm all the way done, I notice here I have another perfect square minus a perfect square. We just talked about you may do nothing here. You will always end up with a b term if you tried to factor that. So I would have 3 times x squared plus 36. Now the square root of the first term, square root of the c term, one will be plus, one will be minus. Now I would like you, and I know I've only given you 2 examples, to find this one on your paper. Think through the process just like we were doing. Give it a whirl. Show all your work. So when I work through mine, we can see what we're doing the same, or we can see what we're doing different. Please take a moment, pause the video, give that one a whirl. Thank you for pausing the video. All right. My first question, and I sure hope it is yours, is can we make it simpler? We sure can. We have a greatest common factor of 4. So I'm going to distribute backwards and take out the 4. I get y to the 4th minus 625. We did simplify it. We can never apply the word prime to that. Now, binomial with a subtraction sign. Is that a perfect square minus a perfect square? It is. The square root of 625 is 25. So I would have 4 times the square root of the first term minus the square root of the second term. And you'll have one that's positive and one is negative. Negative 25, positive 25. Again, we got one step further down the chain of simplifying. Okay. We know we can do nothing here. This portion is done. I can't factor it, or I would end up with the center b terms again. But we have a perfect square minus a perfect square here. So I drop down the greatest common factor, y minus 5, y plus 5, square root of a, square root of c, one is minus, one is plus, and drop down this. Excellent job if you were able to get here. One thing I noticed about this one though, if we look back at the original problem, and I'm going to have to write kind of scrunchy, if I forget to ask myself, can I make it simpler? Well, the answer is yes. Pretend I forgot to ask, can I make it simpler? Is this a perfect square minus a perfect square? Oh, it sure is. So then I would take the square root of the a term for 2y, square root of the c term, which is 50. So I'd have 1 plus 50 and then the other one minus 50. Phew, we did something. But I'm hoping that you notice, wait. Whoop, I forgot all my squares. We have greatest common factors floating in those parentheses. What's the greatest common factor remaining here? 2. Greatest common factor remaining here? 2. So you're going to need to keep factoring. While I can factor a 2 out of the first one, leaving me with y squared plus 25. Factor out a 2 on this one would leave me with y squared minus 25. I'm going to combine these two. Remember, you can multiply in any order. So that would then just bring me back to this step up here, and I would realize I need to break that apart. Very confusing. Always ask yourself, is this the simplest I can do?